Hey guys, this is Daniel. I wanted to give you an update on the Dragon and the Hornet. I have Gabe here, who's going to give you a little information on our progress.
How's it going? So let's see. So first let's go over the hardware a little bit. So we have the Dragon hardware all built up here, and we can see that we have the main PCB, printed circuit board, and then we have the battery here, the li-poly, and then the coil on the back. And these three parts working together here, we can throw that on the Qi charger and show that the Qi charging is working. Sweet! We have an RGB LED right in the middle here, and then we have two LEDs that are showing whether or not the device is being powered by the Qi charger.
And I'm just going to hide the other LED so you can see.
Yeah, it's quite bright.
It's quite bright, but yeah.
And so when we take it off of the Qi charger,
There we go.
we can see that the main LED just stays on, and the other two LEDs that indicate the power status have been turned off. And so that is just a demo really quick of the Qi charging capability. Let's go ahead and set that aside. And then here is our form factor 3D printed Dragon prototype case. And we can see that in the center we have a button here.
And this button is going to be actually white. It's just for 3D printing purposes, it was black.
Right. And you can't really see, but there's a pebblebee logo across the top here. And the RGB LED down here, which is quite bright, can be seen through the case there, as well as when it's on the charger. You can see that there's a red LED that turns on, as well as a second blue LED, and that blue RGB LED won't be on, so it will be fairly easy to see the power status. So effectively, if you put this on the Qi charger and it was not properly charging, you would be able to detect that by moving it around until both the blue and the red LEDs turned on. And I know it's a little hard through the video to see that because it's quite a bright LED that's kind of washing out. But basically that'll be something where you'll say, I want to charge this, I'll throw it on here. Oh, looks like it's charging. Good. So it's quite straightforward. So right now this device, the whole time we've been talking here, has also been connected to the iPad and communicating. And by the way, we can just show really quickly on the back side of this. I don't know if it comes through on the camera there. So we have a translucent case here that we have for the 3D print, and we can see that's the coil back there that we're using to get the power from the Qi charger. So now that I'm holding it in my hand here, we have the iPad app that's running, and we're collecting the raw data in real time here. So as I hold this in my hand and I'm looking at accelerometer data, as we see up here, I have a pretty static signal, and then if I go ahead and start shaking it, I can start to see that the data in one axis, the z-axis, is changing. I can rotate it and then do the same kind of action, and then rotate it 90 degrees from that, and then do a similar kind of action, and see that all three of my axes are responding. I can move over to my gyroscope, and on the gyroscope, of course, we're looking at radial angular velocity actually, and this one here is a little tricky because I don't have a smooth way to control this, but basically I can focus most of the velocity along one axis or another. Oops, you can see that.
And I can tell you dropped it
yeah. And then one of the things, and then let's go over to the magnetometer, and we can see that as we either rotate it or flip it, the magnetometer axes are changing. So we can definitely see that all three axes are working. And we've also been working on some of the sensor fusion work, as well as some of the built-in functions that allow us within the different chips to detect different kinds of events, and those are actually pretty cool. If we look at a tapping type event where the device were to be jarred in some way, either by tapping or being dropped, this event of tapping, I'm focusing on just this particular type of single tap event.
And you can see this increment here.
Yep, and we can see that it basically is occurring, and this is the timestamp associated with it. And then for the double tap event, this one is a little trickier. There we go. And of course, this one is a little tricky because it has to detect the two different events.
So maybe if we do...
And we have some different time periods associated with it. So
it just needs to be a little harder. There you
go. Yeah, there we go. And then similarly for significant motion is meant really to be for like a very substantial dropping event where it hits the ground. So actually I don't want to do that because it will probably jar the internal
plastic 3D printer as well.
Yeah, so I don't want to break our prototype here. And then let's move on to tilt. Tilt is basically something similar to your iPhone or Android phone where you rotate it and then the picture will rotate, for example. So this, you rotate it and then wait about a second or two, and then it detects that it's been flipped over or rotated substantially. And so you can rotate it in a couple different axes and it'll update after it has detected that change has occurred. Let's actually go back to the accelerometer while we're doing this here. And then if we go to the step counter, the step detection is as you would expect. If you're walking along with this, you'll start to get events associated with detecting that you're walking. So you can see that that's updating fairly nicely, so you could definitely use this pretty easily as a step counter. Then we can have the inactivity mode here, where if you basically move it around for some period of time and then set it down, it will detect that there's an inactivity event. And so that takes a few seconds and then it just updated. And then very similar to inactivity is a wake up type event, where if it's not moving for a period of time and then you move it, it will immediately keep activating, basically because it keeps seeing that there's new data, new activity. And then if we go to 6D and 4D, these two are quite similar to each other. They effectively are different orientations that are associated typically with smartphones, similar to whether or not the device would be rotated kind of like this, or all of these different orientations. So basically you can figure out not only has there been a tilt event that has occurred, but which way is the thing facing. So you can effectively tilt it like this, tilt it like this, tilt it like this, all of these different directions you can tilt it. So 6D gives you the most information about, it's not encapsulated here, it just tells you that the event has occurred, but it tells you the most information about which orientation you're in. So this is all information that would be passed up to the app that developers could use in lots of different ways. So I think that's a
awesome.